Okay, so I'm now going to do a analytic geometry problem that is find the points of intersection. So find points of intersection of r equals 2 and r equals 4 sine theta. So first what we should do is, if you can't see the graphs of these in your head, you probably should graph them out by hand just so you have a general idea of what's going on here. So we know that r equals 2 is just simply the graph of a circle with radius 2. So here's 2. And that will look something like that. There. And r equals 4 sine theta is a circle tangent to the pole here with a diameter 4. Like that. So we know the points of intersection are going to be here and here. So we have a general idea that there's going to be 2 points of intersection, one in the first quadrant, one in the second quadrant. So now what we do is set these two equations equal to each other. So since they're both solved for r, we just say 2 is equal to 4 sine theta. So that means sine theta is equal to 1/2. Okay, so since sine of theta is equal to 1/2, there are two coordinates that have sine of theta equal to 1/2. And it's easiest if you have a unit circle or can draw one to see what this looks like. You'd have, I'm just going to draw the top half of the unit circle. You have, of course, your 45-degree angle lines, 60s, and 30s. Hang on, there, 30s. So it goes square root of 3 over 2 comma 1/2 and square root 2 over 2, square root 2 over 2, 1/2, square root 3 over 2, and I'm only going to copy over this point because this is the one of interest, minus square root 3 over 2, comma 1/2. So here are your two points with a sine value of 1/2. And what angles are these? Well, the unit circle goes pi over 6, pi over 4, pi over 3, pi over 2, and then it goes over here would be pi. This would be 5 pi over 6, and of course I could fill these in, but we're just interested in these two angles. These are the two angles that have a sine value of 1/2. So theta is equal to pi over 6, and theta is equal to 5 pi over 6. And these are the two angles where you're going to have your points of intersection. Now, of course, we need, for a point, it's going to be in r comma theta form, where r is the radius, which would be the distance from the pole, and then theta would be the angle. Well, we found theta, now we need to find r. And basically we do that by plugging theta into either one of these equations. Now, this one's a bit different because we actually have an equation that says r is equal to 2 with no theta. So that means that any point of intersection is always going to lie on r equals 2. So we have our 2 points of intersection at 2 comma pi over 6 and 2 comma 5 pi over 6. And this is the answer to the problem.